Yes. So, first order of business. I am very, very, very good at pattern recognition. For example, if I were to ask you to count to 10 and to write your work down, do one of these numbers look different than the others? Oh, sorry. Do one of these numbers look different than the others? Now, I made this obvious for you. To me, there are way subtler things that I can pick up on. For example, how many digits are you using? Are you writing all your answers as 72.3, 83.5, and then all of a sudden we get down to 33.0 when the answer should have been 33.0.5. To me, this screams different than these. Now, to you, this is clearly obvious. One of these numbers, this is equal to 7, but it's in scientific notation. This one, for some reason, decided to switch to using two significant figures when you might have had, for example, another answer that was 70.0053, and this is like 2, and this is 1. You're writing a lot of digits, and all of a sudden you round. This screams to me that something is fishy. I am well aware that the answers to a lot of homework exist on the internet. I'm also aware that the two answer keys on the internet for dimensional analysis have one question wrong. For example, here's your homework. Turn to 17. What does your answer say? Why'd you put 70? What'd your calculator say? You can go grab a calculator and do it. Now, I told y'all you didn't have to worry about significant figures. You should have gotten something like 73.3 something. Which is very suspicious when I see that you rounded to one significant figure. When on other problems, you weren't rounding to one significant figure. Then if we look at 26, the online answer sheets get this problem wrong. They come up on problem 26 as 3,300 minutes. This is way off from the correct answer. They made a mistake. Alpha, what? You can just push the divide symbol. Just every time you're putting in numbers on the denominator, just proceed it by division. So if you had 5, 7, and you had 2, and you had 10 and 3, you could plug into the calculator 5 times 7 times 10 divided by 2 divided by 3. You could do this. Paul, if you have 5, 7, 10, 2, 3, you can put in star 7, star 10, slash 2, slash 3. Yes. I don't know, clearing it? You don't have to clear it. All you need to know how to do is divide and multiply. And what do you get? So why'd you round it to 70? Yeah. Again, cheating is not allowed. Looking up a single answer is the same thing as copying the whole thing. And then that answer sheet was wrong on 26. And I'm probably going to give you a 0 for this whole paper, even if you did everything else by yourself. Currently, it's like a... hold on, let me mute. No, it shouldn't. Alright. So I'm going to go, and this is mostly for the remote learners, and look to see what your answers are, and if they match the ones on the answer sheet, then you will also get a 0. Again, I am very, very good at pattern recognition, like to the point where, like the most subtlest of things stand out to me. Usually, I pick my battles, which means I might catch you cheating and be like, I don't want to sit there and have to prove it. But especially when the entire class, both classes, turned in with answer key answers, it screams to me that everyone's going to get a 0. Oh, I already gave you that. I was wondering why I was missing one. Alright. So we're going to work on this together before I pass out the homework. So, definition of a mole. A mole is defined as 6.022140076 times 1023 of some chemical unit. This chemical unit can be atoms, it can be molecules, it can be particles. It's just some unit. It's a counting number, like a dozen. You could have a dozen cookies, in which case your unit would be cookies. So, we've been doing dimensional analysis and the conversion factors. We're going to be using that throughout the entire year. So here we're trying to convert we're asking how many moles are in 34 grams. So we're trying to convert grams into moles. We're going to have two main conversion factors. We're either going to have the conversion factor of 6.022 times 10 to the 23 chemical units is equal to 1 mole, or we're going to have molar mass. Remember, molar mass is going to be off the periodic table, and it tells you grams to moles. So if we look at this problem, we have 34 grams of copper hydroxide. By the way, I'm going to be saying the chemical name of these chemicals. It's possible I can make a mistake because some of them, like H2O, is water. The technical name for it is the hydrogen monoxide, but we call this water. Chemicals like this, I'll get to it in a second, have a unique name that you just have to memorize. So there's going to be a few chemicals, in which case, like propane, methane, they all have names you have to memorize. But for this one, it's copper hydroxide. Cu is for copper. I might make a mistake, but you should know I'm referring to this chemical. So we need to find out its molar mass so we can convert from grams to moles. So for copper hydroxide, this 2 on the outside means that what's in parentheses is repeated twice. You basically multiply everything inside by 2. Another way of looking at it is that there are 2 of them. Just like in math, if you have Just like in math, if you have a 2 outside, it multiplies against everything inside the parentheses. So you can think of it more like this. You have O2 and H2 inside, because the 2 goes inside and multiplies it. And if there's no number beside it, it's just a 1. So we have 1 copper, 2 oxygen, and 2 hydrogen. So looking it up, that'd be 1 times 63.546, 2 times 15.9994, and 2 times hydrogen, 1.00794. Once you add all that up, it would be 97.56068. And remember that this is technically AMUs. But to convert between AMUs and grams per mole, we cross out the AMU and just write grams per mole, or molar mass. I'll write that in words. To convert atomic mass, this is the mass on periodic table. to molar mass, replace AMU with G/mole. And the abbreviation for mole is MOL. I saw on y'all's homework, some of y'all left off the M, or y'all put M for mile. M is for meter. MI is for mile. MIN is for minute. If you see me abbreviate something, abbreviate it exactly how I abbreviate it. Because unless you know the proper abbreviation for it, chances are you're wrong. For example, A stands for acceleration. The capital A stands for amps. The abbreviations, the capitalizations are extremely important. For example, lowercase l stands for length, usually written cursive, and capital L stands for liter. So now we have our conversion factor. There is 97.56 grams per 1 mole. So we can set up our grid. That's another thing. I teach differently than what you'll find online. I teach this grid method. Another method that I see, or method that a lot of teachers teach, is instead of using a grid, you have A, you have B and C. I teach this grid. What they'll do is they'll come over here, A over 1 times B over C. I don't like this grid. Yeah. And again, whenever I see that you're using the grid, and then all of a sudden you switch notation, it just screams to me something weird is going on. So we're given 34 grams, and we need to convert grams into something else. We need to convert it into moles. So we begin by doing our grams on bottom and our moles on top. So we know that there are 97.56 grams in 1 mole. Grams cancel each other out, and we get an answer of 0.3485 mole. By the way, from now on, whenever you do homework, I want at least, at very minimum, 4 significant figures. So at least 4 numbers. If you get an answer that's like exactly a half, like 0.5, you can write 0.5 if this is that. Or if it's 0.50000001, you can go ahead and round this to 0.5. However, if you get an answer that is 0.30123, do not round it as 0.3. I want at least 4 or 5 numbers. So you could round it to 0.3012, but this is the least you can round it to. So from now on homeworks, write at least 4 or 5 numbers and always show your work. So the next problem, how many moles are present in 2.45 times 10 to the 23 molecules of CH4? This is methane. This is a trick question. We don't really need to know anything about methane. We don't need to know its molar mass or its conversion factor grams to moles. We're converting molecules to moles. Molecules to moles is going to use Avogadro's number. we know that there are 6.022 times 10 to the 23 molecules in 1 mole. So we use this number. So we start with what we're given, 6.45 times, I said 6, I meant 2. 2.45 times 10 to 23, not 20, yeah, 23 molecules. By the way, there is no way to abbreviate molecules. If you put MOL, it's moles. So you have to write the whole thing out. And we know that there are 6.022 times 10 to the 23 molecules in 1 mole. Molecules cancel each other out, giving us 0.40684 mole. So problem 4 asks us how many grams are there in 3.4 times 10 to the 24 molecules of ammonia. So we're trying to convert molecules into grams. There is no straight conversion factor. We need to first convert molecules into something else. Luckily, we know we can convert chemical units into moles. So we can convert something like molecules directly into moles. We begin by writing what we're given. Cancel out molecules and gives us moles. We put the number on bottom. 6.022 times 10 to the 23 molecules to 1 mole. And now we can cross out molecules, and we're in moles right now. Now we need to convert moles into grams. Moles into grams is a molar mass. So we need to find the molar mass of ammonia. So that's 1 nitrogen and 3 hydrogen. So 1 times 14.00674 plus 3 times 1.00794. And that gives us 17.03056 grams per mole. Now we have a ratio of grams to moles. So we need to cancel out moles and get grams. So this says there are 17 grams for every mole, or 1 mole. So we would put grams on top and mole on bottom to cancel it out. So it would be 17.03056 grams for 1 mole, which cancels out the grams, giving us the moles, giving us just grams. Doing this times that divided by this gives us 96.1539 grams. So you would write into your calculator 3.4. Actually, I'll show you. So typing that into your calculator, so what you do, 3.4. By the way, if you see on your calculator somewhere right here, there's a double E. I always use that. So if I do second, because it's in blue, the double E symbol, you'll put E, and you don't have to put times 10, you can just put 24 after it. And then again, you're multiplying all the numerators first, so you hit multiply. No, it's 24. Yeah, you see it in the problem? 24. So you type in 17.03056, and now we divide by the denominators, so 6.022, and again, you can do second and E to get the 23 after, and then technically you would divide by 1, but there's no reason to divide by 1, you just keep hitting divide by the next numerator, and then hit divide by the next numerator over and over, so you're finished. Press enter, and we get 96.1539 on your answer. So doing the next problem, it says how much does 4.2 moles of calcium nitrate weigh? So we're converting moles into grams. So we need a conversion factor between grams and moles. That means molar mass. So calcium nitrate, that's 1 calcium. Let me write this all the way out. So we have CaNO3 with a 2 beside it. Again, this 2 is going to distribute inside. This is the same thing as N2O6. The 2 multiplies with everything in it. So we have 2 nitrogen and 6 oxygen. So that'd be 1 times 40.078. That'd be 2 times 14.00674. That'd be 6 times 15.9994. Adding that all up, we get the conversion factor 164.08788 grams per mole. So we're given 4.2 mole. We plug it in so the mole is on bottom, which it is. It's on the denominator. We plug it into the denominator side. So the 164.08788 grams per 1 mole. That's plugging this into it. Mole cancel out, and we're given grams, which is technically not a weight, but the act of weighing it, you would weigh it in grams, which is more mass. So 4.2 times that gives us an answer of 689.169 grams. So it says, what is the molar mass of magnesium oxide? Or monoxide? It's magnesium oxide. So it would be this plus that. So remember, molar mass is in grams per mole. So we can remove the AMU, or don't write AMU and put G/mole. So it'd just be 24.305 plus 15.9994. And that'd be 40.3044 grams per mole. So we can see a lot of similarity between molar mass and atomic mass. They use the same numbers, but different units. By the way, for remote learners, that is the code word. Code word. I closed it. So you couldn't see the code word. Yes, but then people in class have been texting people at home. So atomic mass measures the mass of the individual atoms or molecules. So when you state something in atomic mass units, you're actually telling us how much does an individual atom weigh, or how much does an individual molecule of water weigh. When you express it in molar mass measures the mass of 1 mole of the atoms or molecules of the substance. So molar mass refers to the mole mass, while atomic mass refers to the atom mass. And for molar mass, we want to select grams per mole because it is per mole. This is the mass. You could technically measure it in atomic mass units per mole, but that's a super crazy small number, and mole is a super crazy number. So if you had like 0.0001 divided by like a really big number, then you're going to get a stupidly small number. So it's better to use something bigger like grams per mole. Any questions? I suggest you actually doing this on notebook paper. Oh no, this is the actual homework. Yes. That's it for the day.